Hi everyone, my name is Maria and I'm here to present to you GarmentCodeData, our latest work. This project was very much inspired by the recent progress in the learning-based solutions for sewing patterns, specifically sewing pattern reconstruction and generation based on point clouds, images, and text inputs. A sewing pattern is a basic representation of a garment, of how the garment is constructed. It usually consists of a set of panels that represent the individual pieces of fabric. Each panel is usually represented as a closed piecewise curve, where edges are either straight lines or smooth curves. Each panel has an information of its safety placement around the body so that we know its role in a garment. And the pattern is usually includes a description of stitches of how these panels are to be combined together to form a full garment. Reconstructing and generating sewing patterns is an important task when we talk about the general garment reconstruction problems, but also when we talk about the design assistance for garment design and garment creation. Learning-based efforts in working with sewing patterns stumble over the limited data availability. Unfortunately, the currently available data sets that include sewing patterns and corresponding 3D models or other medium representations rely on the data distribution from the work of 2021 that introduces synthetic data set sampled from 19 basic garment types and included about 20,000 garment designs. Later on, it was expanded to include textures, more materials, and more realistic body shapes and poses, and image-based media representation of garments. However, the core distribution of the designs remain the same. If we look closer at it, we will notice that the designs presented in those data sets are very limited in their diversity. They're very simple, much more simple than the actual garments we may find in the real world. So we wanted to tackle the challenge and try to get to one step closer to closing this tutorial gap. Again, we're taking the path, inspired by the previous work, we're taking the path of synthetic garment generation and basing our work on the concept of parametric garment design. In parametric garments, a designer, instead of creating one specific example of a piece, describes a design space which can then be explored either manually or sampled automatically into a bunch of different garment designs and garment elements. The latest work in this area is GarmentCode. It's a domain-specific language for describing parametric sewing patterns that supports design and body-related parametrization and contains a bunch of features that simplifies the design process and definition of parametric patterns. The parametric sewing patterns designs applied with GarmentCode show much greater variety and complexity of designs compared to previous work I showed you before, and also showcases the ability of transfer any of those designs between different body shapes. So it closes a little bit, takes an additional step forward into the seam-to-real gap in terms of garment complexity and body support. However, that work only introduced the design tools for creating such parametric spaces. However, here we would like to be able to utilize those tools and create a whole data set for learning-based purposes. So in this work, we have set up a synthetic data generation pipeline based on the GarmentCode parametric design space. The first step of the pipeline is taking the body samples. We trained a custom statistical body model to draw a variety of body samples from and created a set of algorithms for evaluating different types of body measurements that are required for fitting our patterns. Here you can see some of the examples on the extreme shapes from our statistical body model and how they automatically evaluated body measurements are used to create the perfectly fitted jumpsuits here. So once we have the body shapes and their measurements sampled, we can go on and create the sample of the design space. However, if we naively use the design space provided by GarmentCode, we might end up having a very unrealistic garment samples. Sometimes they're too extreme in the design. Sometimes they don't even look like garments at all. So the problem is that the new design space in the GarmentCode project is so big and incoherent that we often end up in the local areas that are not representative of a garment space domain. So in this work, we have invested a lot of additional engineering effort into making the design space more coherent, improving the parameter dependency on each other and on the body measurements. In addition to that, we added probabilistic control over the design space by introducing a default value probability. So when we sample a particular design parameter, we have a control over how often that parameter looks like a default value. This allows us to strike a nice balance between representing typical features appearing in the common design, while also being able to explore more interesting parts of the design space that create a variety and complexity of design. Here are some of the examples of the successful design samples as draped on the neutral body shapes. As you can see, there are some with more regular styles, while some others exhibit a more extravagant features. Once the design sample is drawn and fitted to a body shape that was sampled previously, which is done using the GarmentCode program, all that's left to do is to create the drape of the garment and create a 3D mesh corresponding to that particular garment design. So what we do is we take the pattern, we create the meshes for individual panels, connect them according to the stitching information, place them around the body, and then run a physics-based simulation to create the final drape. Now that pipeline may sound quite trivial since the closing simulation has been studied for a long time. However, when we try to perform the draping on scale, where we have a variety of designs and we're not able to intervene manually with every one of the design simulations, we found that there is a lot of issues that require additional solutions to maintain the scalability and reliability of the drapes. The first issue that we stumble over is the self-collisions of the initial state. The simulators tend to preserve the self-collisions that are present in the initial state, so we had to add additional solutions to combat those. One of the main examples is pulling towards the corresponding to the body parts that correspond to each piece of the garment, to each panel of the garment. It allows us to create collision-free drapes, even in these extreme cases where we have a lot of initial intersections. Apart from self-intersections, we do encounter a lot of intersections with the body when we initialize the garment. So we have some additional hacks to combat these problems. Where we add an additional constraint that pulls the vertices inside of the body model outside. Secondly, we allow some filtering on the body parts that we have a collision with, so that we may ignore the body parts that are not participating in the drape, for example, like the arms and the skirt. Finally, when we stitch the garments together, sometimes we see that some of the parts of the garment are not located where they should be. So we're employing attachment constraints to place the garment parts on the area where they should be dressed on. For example, the stencil skirt, we use the waist level constraint to put it on the waist area. So finally, we put this pipeline together by drawing body samples and design samples, putting them through the garment programs in order to create the sewing patterns. We chose one of the 3 materials that represent different behavior of the fabric, and drape them on it using a fast GPU XBBD simulator with the additional constraints that I just described. The simulation process is draped successfully about 72% of the time, which is already something that we can work with at scale. It takes about 30 seconds per pattern on the quite high resolution meshes with 30,000 faces on average in one garment mesh. So using this pipeline, we created a new data set, which is called GarmentCodeData, which it is the first data set of garment sewing patterns and corresponding 3D models that contains more than 100,000 designs and is draped and fitted in a variety of body shape. Each design is draped on a random body shape and also on the corresponding neutral shape, so that fitted to and draped on the corresponding neutral shape, so that we have a common space of the designs. The data set that we present takes an additional step forward towards closing the sim-to-real gap for the data available for garment processing. However, of course, there's still much work to be done. What is need to be included is the ability to model layered garments, expand the ability to model materials and material combinations, adding decorations and furniture like buttons and zippers, and many other features that needs to be included. But for now, we're sharing our current data set. The code for the pipeline is fully open source. It's available on GitHub. The data is also shared free of charge, and we're looking forward to see what people will be able to do with the data that we share. Please enjoy and put it to good use. Thank you very much for your attention. We thank everybody who contributed to this work with their skills, with their attention, with their support, and with their financial investments. Thank you very much. This is the link to our project page. Feel free to visit and get all the links that you need regarding this project. Thank you.